Hello everyone, my name is Dr. K.C.H. Apparao, working as an Associate Professor in Mechanical Engineering Department. Today I would like to explain about nomenclature of the IC engines. In previous class we discussed the introduction of IC engine. What are the different types of IC engines? What is the difference between internal combustion engine and external combustion engines? So all these things explained in the previous class. Now we'll see what are the different nomenclatures of IC engines. So before going to our lecture, just we'll see the course outcome of the subject, mainly unit first. So at the end of the course, students should be able to classify the fuel injection and ignition systems to pretend the application of combustion chambers, chamber types such as T-head and overhead. So this is the outcome of this unit. Okay, you know that heat engine, any engine that converts the thermal energy or heat energy into mechanical work output. So that is called heat engine. Here some examples of heat engines are also given. One is steam engine, steam power plant, jet engines, gas turbine power plants, diesel engine, petrol engine. So all of these heat engines, because in these engines chemical energy of the fuel is converted into mechanical work output. Okay. We already discussed in previous class, heat engine, two types. One is internal combustion engine, IC engines, simply called as, and external combustion engine, simply called as EC engines, EC, external combustion. Okay, previously external combustion engines are used rapidly. After that, internal combustion engines are replaced with the external combustion engines. We discussed in previous class also, because external combustion is nothing but combustion takes place outside of the cylinder. It requires huge space and efficiency also less compared to internal combustion engine. But internal combustion engine, combustion takes place inside the cylinder. So it is a compact engine and it requires less space. So it gives good efficiency, mechanical efficiency also. So internal combustion engines are replaced with the IC engines nowadays. Okay, in last class we already discussed different types of heat engines. Types of engines based upon the stroke. Type of, it means two types of stroke engines are there. One is the 4-stroke engine, second one is the 2-stroke engine. Similarly, we classified the engines based upon fuel also. It means petrol engine, diesel engine. So next, by using the ignition system also, based upon the ignition system, two types of engines are there. Spark ignition and compression ignition engines also. So based upon the system, there are different types of heat engines are there. There are many classifications are there based upon the cylinder also. Single cylinder engine, multi-cylinder engines. Okay. So in which mainly 4-stroke engine and 2-stroke engines are very important. In 4-stroke engines, we know that the complete power cycle is completed. The one power cycle is completed in 4 strokes of the engine, or 2 revolutions of the crankshaft, or 2 revolutions of the flywheels. But 2-stroke engine, the power cycle is complete in 2 strokes, or in 1 cycle of the crankshaft or flywheel. Okay. So in which we know that the stroke is nothing but we already discussed in okay, in this class we'll see that one also. First, these are the block diagram of IC engine. here we can see the different parts of IC engine. So you know that this is the combustion chamber. Okay. So inside the combustion chamber, the piston, this is the piston, moves up and down, reciprocates and high to up to down. Okay. So this piston is connected to crankshaft, this one, by connecting rod. This is nothing but connecting rod by with the help of pin, guardian pin. Okay. So next we can divide this one upper, we can say, so this is the BDC and TDC, we'll see later also. Above portion, top portion of the chamber, it contains some valves also. So this is the inlet valve, or we can say inlet manifold valve. So this is called exhaust manifold valve. So this is the, so in this exhaust manifold, exhaust valve is fixed. In this inlet manifold, inlet valve is placed. So this, by the help of this inlet valves, charge will be taken. Charge is nothing but air fuel mixture. In case of C engine, only air will be taken through inlet valve. Okay, exhaust valve to scavenge the unnecessary gases, smoke from the combustion chamber. So we can say this is the combustion chamber because the combustion takes place at the top of the cylinder head. Okay, so here we can see this is the spark plug, which gives the spark for the ignition purpose. We'll see later also. Okay, these cams are run by camshaft and cam mechanism, by the help of the cam mechanism. Okay, here just like cooling water shirts for the cooling purposes, or cylinder blocks. So this one is the cylinder block. This is the crankshaft. Shaft is connected to any motor to run that motor. Okay, so you know that this one, the piston. So this is the cylinder head and all these things. So valve springs also. Valve springs are used to operate the valve opening and closing by the help of cam mechanism. Okay, so this is the intake valve. This is the exhaust valve. So these are the just different parts of IC engine. Now we'll see what is the importance of different parts of the IC engine. The first one is the block. Okay, so block is nothing but the body of engine containing all the cylinders made. So the cylinders are made up of cast iron. Previously cast iron was used. Nowadays aluminum is using rapidly because aluminum aluminum has good corrosion resistance compared to cast iron. Also less weight and it can withstand the temperatures also. Okay, so compared to cast iron, aluminum is preferable nowadays based upon the mainly weight. If we reduce the weight, automatically vehicle weight will be reduced, automatically pollution will be reduced. So next one, cylinders. Okay, the circular cylinders. Which one? This is the cylinder, you know this. This is the circular cylinder. Cylinders in the engine block, in which piston reciprocates. Piston moves upward and downward direction, or back and forth. It reciprocates. Okay. So next one, head. So head is the piece which closes the end of the cylinder. It means the head. So this is the head portion. You can see. So it closes the end of the cylinder. Usually it contains parts of just like a clearance volume. So clearance volume, because the combustion. So it means in compression stroke, all the charge will be collected in the clearance volume. It is the top of cylinder head. Okay, so we can see. Next to combustion chamber. Combustion chamber, it is the end of the cylinders, end of the cylinder between the head and the piston face. Piston face when the combustion occurs. It means So this is the combustion chamber. If piston moves up to this position, that is called TDC, and in bottom it moves up to this position, that is the BDC. Okay, so above the BDC, TDC, so that is called clearance volume. The clearance volume, the charge will be collected and the combustion takes place. Okay, the size of combustion chamber continually changes from minimum volume with the piston is at TDC at the top portion, and the piston is at the TDC position. It means here TDC position. So minimum volume is at the piston is in BDC position. So that is the volumes. Next to crankshaft, you know that is the rotating shaft through which engine works. So engine works, output supplied to external system, either it may be any motor. Okay, that motor is connected to the shaft, and the shaft is rotates, so automatically the motor also will be rotated. Okay, so it means reciprocating motion of piston is converted into rotary motion of the shaft. Okay, that is the main. The crankshaft is connected to engine block with the main bearings. It is rotated by the help of reciprocating piston. So reciprocating motion of the piston is converted into rotary motion of the crankshaft. So this rotating shaft is connected to any engine which will be work. Okay, so the offset is sometimes called crank throw or crank radius. You can next connecting rod. So it connects the piston and the crankshaft. Okay, the rod connecting the piston and rotating crankshaft. Okay, usually made up of steel or Li forgings also in the most engines. Okay, but maybe aluminum also in some engines, some cases aluminum also using. Next to piston rings, these are very important. So piston rings that fits in the circumferential grooves, that is the piston, it has some circumferential grooves. So in this grooves, these are fitted. Okay, so it gives the tightness or sliding between the in the cylinder. Okay, so without any leakage of charge, over tight fitting or just it sliding, or just it forms a sliding surface. So for the sliding surface, we use the just piston rings. Next one is the spark plug. It is very important. It uses in SA engines only, spark ignition engines. It is the electrical device used to initiate the combustion. So combustion takes place by spark ignition. So spark plug gives the spark. So for the ignition of for igniting the air fuel mixture. Okay, usually it is used only in SA engines. So it creates some high voltage discharge from so circular inner electrode to outer electrode. So like this one, this is the outer electrode. So the space is ionized. When the charge is passed from inner to outer, there's some lighter spark, the spark will create. So that spark helpful to ignite the charge in the combustion chamber. So next one is the exhaust manifold. So exhaust manifold means exhausting of unnecessary gases or smokes, just piping system through which it carries the exhaust gases. So it carries exhaust gases away from the engine cylinder, just like scavenging purposes, usually made up of cast iron. Okay. So next one, intake manifold. Intake manifold are just like piping system which delivers the incoming of the charge. Charge means air fuel mixture in case of SA engines into the cylinder. Okay. So manifold mainly used to take the air fuel mixture which is coming from the carburetor. So carburetor is a device which is used to prepare the homogeneous mixture of air and fuel. Okay, so that air-fuel mixture is taken into the cylinder with the help of intake manifold. It is also usually made up of cast metal or plastic or composite material like aluminum composites. Okay. So next, now we'll see the terminology of ICE engines. What are the important parameters? First, we'll see this one is the just like engine. This is the inlet manifold. This one is the spark plug. This is the exhaust manifold, inlet manifold. Okay. So in which inlet valve will be placed, in which exhaust valve is placed. Okay. This is the TDC, top dead center. This one is the BDC. So in between TDC and BDC, the piston will reciprocate like this one. This one is the crankshaft. Okay. So this is just like block diagram. So it means bore is nothing but outside diameter of the piston or inside diameter of the cylinder. This is the bore. So it is represented by D. Okay. So next one is the stroke. Stroke is nothing but the piston moves from top dead center to bottom dead center. So this is the dead center, means that is the point. Beyond this one, the piston will not move upward direction, or beyond this one the piston will not move in downward direction. So this is the dead centers for the piston. So between these two, the piston will reciprocate from top dead center to bottom dead center. Okay. So the distance between the top dead center to bottom dead center is nothing but a stroke. Okay. So it is represented by L. So next one is the swept volume. Swept volume is the volume between the top dead center to bottom dead center. It is the maximum volume swept by the piston. Okay, so in this volume, the piston will move from top dead center to bottom dead center. So it is the maximum volume swept by the piston when it moves from one dead center to another dead center. Okay, it is the swept volume. So next one is the compressor ratio. It is very important. So this is ratio is different for the different engines. Okay, it is a critical parameter in IC engines. Okay, so that measures how much air fuel mixture is compressed during the compression stroke. Okay, it defines the ratio of total cylinder volume. Total cylinder volume means this is the swept volume. You know this one. Vs. Above the swept volume, it is the clearance volume Vc. So total volume of the cylinder means swept volume plus clearance volume by clearance volume. So Vc. So this is nothing but the ratio of this one, the ratio of volumes of total volume by clearance volume. That is nothing but a compressor ratio. Okay. So we can see the block diagram. This is the bore, inner diameter of the combustion chamber or cylinder, or outer diameter of the piston also, both are same. The dead centers in between the piston will move. So this is the top dead center, this is the bottom dead center. Okay. So the difference between the top dead center and bottom dead center. So this is the L, it is a stroke, because the piston moves from top dead center to bottom to top. It means between these two dead center, the piston will move. So that is nothing but strokes. Okay. So next, this one is the volume. This volume, the piston will swap this volume. That is the swept volume. Swept this volume. This is the Vs represented by Vs. Okay. Above this one here, this is nothing but clearance volume VC. Okay. So compression ratio CR is equal to total volume. Total volume means VS plus VC by clearance volume. Okay. So mainly, so this compressor ratio is different for the different engines, mainly for the petrol engines, gasoline engines. The range of compressor ratio is 8:1 to 12:1. It means 8 is the total volume, 1 is the compressor volume. So 12 is the total volume, 1 is the compressor volume. It means V total to VC. Okay. So this is the range. In between, we can just the SI engines compressor ratio will vary, because beyond this one, if you increase the compressor ratio, mechanical efficiency would increase, but there may be chances for knocking pre-ignition. We'll see what is knocking, what is the effect of knocking also in next classes. Okay. So our compressor ratio leads to some defects, and less compressor ratio also causes to some problem. So there is some range. In between this range, we can vary. So we have to identify the optimized compressor ratio for the any ICE engines to get the good output, good mechanical efficiency. And the range of the diesel engines in which ignition takes place like compression of the fuel. So the range of this one is equal to 14:1 to 22:1. Okay. So diesel engines rely on the compressive ignition. But in SI engine, means petrol engines, ignition occurs by the help of the spark ignition. Okay. So higher compression ratio leads to more combustion. It means it is efficient fuel combustion, but improves thermal efficiency also. Power output also will be improved, but it may causes for knocking. Knocking is the defect of it is the abnormal combustion. Okay. So particularly in gasoline petrol engine. Okay, lower compression ratio, so it reduces the risk of knocking. Okay, but generally it reduces the efficiency of the engine also. Less efficient of combustion, low power output will release. So these are the drawbacks. So we should maintain certain range. It means otherwise you have to identify the optimized compressor ratio. So next we'll see next terminology. Air standard efficiency also very important. Air standard efficiency is nothing but thermal efficiency, the output. It is the ratio between the work done and heat supplied for air standard cycle. So it is a theoretical measure of how efficiently a thermodynamic cycle is converts the heat input into work output. So you know that heat engine is nothing but conversion of heat energy into mechanical work output. So it shows it converts the heat input, released input heat is converted into work output. So it is based upon the air standard assumptions. There are different types of air standard cycles are there. The air standard efficiencies depend upon type of thermodynamic cycles like Otto cycle, diesel cycle, dual cycle. These things we'll see in further classes. Next, okay. First, we'll see the four-stroke ignition engine, four-stroke SI engine. What are the different strokes in SI engines? We'll see. This is a single-cylinder SI engine. Okay, so the piston moves in reciprocating motion. That reciprocation motion is converted into rotor motion of this shaft. Okay, we'll see. Here, 4 strokes. It means so 4 phases are there. One is the intake stroke or suction stroke. So next one is the compression stroke. Third one is the power stroke, expansion stroke. Last one is the exhaust stroke. So these are the 4 strokes in 4-stroke engine. So in each stroke, what would be happened? We'll see. Okay. So the purpose of intake stroke, the first stroke is the suction stroke. In the suction stroke, the piston, this piston moves from this is the top dead center TDC to BDC. Okay, the piston moves from top dead center to bottom dead center. So in this case, just like the piston moves from top dead center to bottom dead center, so in downward direction. Okay. So in this case, just like the inlet valve will be open, the inlet valve opens. Through this valve, air fuel mixture comes from the carburetor. The air fuel mixture charge, we can say that is the charge. Air fuel mixture is taken into the cylinder. Okay, so to draw the air fuel mixture into the cylinder, that is the main purpose of the suction. And suction means the piston moves from top dead center to bottom dead center. So in this way, just like when the piston moves from top dead center to bottom dead center, automatically it creates some vacuum. Vacuum means the pressure inside the cylinder is less than the outside of the cylinder. So atmospheric cylinder. Automatically the air fuel mixture comes into the cylinder. The piston moves downward direction from top dead center to bottom dead center. Okay. So in this case, the inlet valve is open, the exhaust valve is closed. Okay. The downward motion of the piston creates the vacuum. Okay. When it moves from top to bottom, it creates vacuum. Vacuum means the pressure inside the cylinder is less than the outside of the atmospheric pressure. So automatically air fuel mixture comes into the cylinder or pulls into the cylinder. So that is the main purpose of the suction. Second one is the compression. So in compression, so we can say, so this is the spark ignition. This is the TDC. This one is the BDC. So in compression means in the suction, air fuel mixture will be taken into the cylinder. In compression, the piston moves from the bottom dead center to top dead center. In this, the air fuel mixture is compressed into the vacuum clearance volume. So that is the compression. So the purpose of this one is that it compresses the air fuel mixture for efficient combustion. In which piston moves from the bottom dead center to top dead center. Okay, so BDC to TDC. In this case, both the valves, inlet valve and exhaust valve, both are closed. Okay, the upward motion compresses the air fuel mixture, increasing the, so when it compresses the air fuel mixture, automatically the temperature and pressure will be increased. Okay, so this leads to pre-ignition or just like preparing for the ignition. Okay, by the help of spark plug, ignition takes place. That is at the end of compression. At the end of the compression, combustion takes place. Combustion takes place by the help of spark ignition. The spark which releases from the spark SI device, spark ignition device. Okay. By the help of that spark, the ignition takes place, the combustion takes place automatically. So at that time, fuse temperature and pressure will release. It means peak pressure will release. Okay. So at the end of the compression, just like this is the combustion. At the end of the combustion, high pressure and temperature releases. That pressure will move the piston from top dead center to bottom dead center. That is called power stroke. So power stroke, it is the expansion stroke. It means the piston moves from top dead center to bottom dead center. So the purpose of this one is to convert the chemical energy of the fuel into mechanical work. So in this case, when the just like piston is moved from top to bottom, automatically just like the reciprocating motion of the piston is converted into rotor motion of the crankshaft. So the shaft is connected to any motor, means automatically that motor will be just will runs. Okay. Okay, valves. Here valves, both the inlet and exit valves also remain closed in portion. In compression, both the valves are closed. In expansion also, both the valves are closed. Okay, so action with the help of spark plug, ignition takes place. Ignition automatically, it means combustion takes place. Due to this combustion, high pressure and temperature will releases. That pressure, generated pressure, pushes the piston from top dead center to bottom dead center with a high force. So due to this movement, automatically the piston moves in the downward direction. So in further strokes, to move the piston from remaining, it means from bottom to the top. So the flywheel, the inertia force which is stored in the flywheel helpful to move the piston in all strokes regularly. It means smoothly. Okay, next to exhaust. Exhaust stroke means in which just like the piston moves from the bottom dead center to top dead center. So bottom to top. In this the just like smoke which was released in the combustion, all the smoke and unburned fuels, all these things will be executed or scavenged from the outlet valves, outlet manifold. Okay, the piston. The purpose is to expel the burning gases from the cylinder. Piston movement. The piston moves upward direction from bottom dead center to top dead center. Okay. See here valves. Inlet valve closed, but exhaust valve is open. Okay, through exhaust valves, all the unnecessary gases, smokes will be expelled. Okay, action. Upward motion of the piston forces the exhaust gases. So because the piston moves from bottom to top, automatically all the gases which are filled in the cylinder, those smoke will be scavenged through exhaust valve. Okay. So finally, there are 4 strokes. One is the intake stroke or suction stroke, in which air fuel mixture will enter into the cylinder. Compression stroke, the mixture is compressed. Power stroke, the mixture is ignited and generated power. That high power just pushes the piston from top dead center to bottom dead center. Last one is the exhaust. Exhaust valve helpful to just to expel the unburned gases from this valve. Okay. So here we can see in the section, piston moves from top dead center to bottom dead center. So automatically the vacuum will create. Here vacuum means the pressure of this vacuum is less than the pressure of atmosphere. Automatically through inlet manifold, air fuel mixture comes into the cylinder. Okay. So in compression stroke, the piston moves from bottom dead center to top dead center. So in this, the charge which is filled in the cylinder is compressed. So at the end of the compression, by the help of spark plug, combustion takes place. Combustion means burning of the fuel that releases high energy. That energy, it means that power and that pressure pushes the piston from top dead center to bottom dead center in downward direction. Okay, last piston moves from the bottom dead center to top dead center. In this case, the remaining which are occupied, the smoke which is smoke and unnecessary unburned fuels which are occupied in the cylinder are scavenged or expelled to the exhaust valve. So these are the 4 strokes. In the 4 strokes, just like one power cycle will be completed. For completion of the power cycle of 4 strokes, it takes 2 revolutions of the crankshaft. 2 revolutions means 316 to 720 degrees movement of crankshaft. This is the functioning of 4-stroke engine. Okay, so this is the 2-stroke engine. Next class we'll discuss this one. Thank you. These are the references for better understanding. You can go through these reference books. Thank you for listening this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.